So I want to look at some problems here in context. These come up and we're looking at shapes here, just kind of drawing on previous knowledge about area and applying it to a situation where we can write an expression and expand it. Remember, expressions are just things without an equal sign, so some way to represent, for instance, in this case, the area of the shaded region. So looking at the first example, we've got an area. You can see it's made up of a rectangle. You have to keep that in mind. This would be a prior knowledge I would expect you to know. The area of a rectangle is going to be the base times the width. Another one you could keep in the back of your head just while I'm at it, reminding you guys the area of a triangle is 1/2 base times height. Anyways, we're dealing with rectangles here, so we need to find an expression for the total area of this rectangle. And so if we knew the width and the base, we could just times them together. So let's think about some way to represent all of this as one thing and all of this one thing, because the base here is actually 5a in distance plus 6. So we can say that 5a plus 6. That makes the base of that rectangle. And just like we have the sides here, we have a 3 plus a 2a will get us that total distance there. So 3 plus 2a. And because we are looking at area, we're going to times the base times the width. So you could put in a times sign there if you want. But again, we don't really need it because of the brackets. So this is an expression for the area, because it's equivalent to the base times the width. And they would like us to write it out in expanded form. So we're going to use claw, if you will, or any way that you like to remember that, FOIL as well, that we expand it all the way through. So 5a times 3 gets us 15a. 5a times 2a gets us plus 10a squared. 6 times 3 gets us a plus, not 9, that's adding. 6 times 3 gets us a plus 18, and 6 times 2a gets us a plus 12a. The last step here would be to look for like terms. I see a 15a and a 12a. We can add those together, so I'm going to write 10a squared plus 15 and 12 gets us to 27a plus 18. And that would be my expression for the area. Looking at the other example, sometimes we have to do a little bit of subtraction, potentially. So instead of finding the area for this whole rectangle, I've got to work out what the area is of this green part here. And I know that all the way from the top to the bottom on the sides there is 7, and that from halfway down, well not halfway, but for the bottom section there it's just x. So if I wanted to find an expression for just the length of that green part of the rectangle, what if I said that was 7 minus x? Because the total is 7, and if I take off that x, I'm left with this piece here, which is 7 minus the x. So I'm going to use that for the width there. And for my base, same idea. I know the whole way across is 4x, and I know that this piece here is just 1. And in fact, I guess I wrote that as kind of a silly example because you don't actually have to do any subtraction there. We are just going to use 1. So times by 1. And that can be simplified to just 7 minus x in brackets. Let's just look at another one just to go through that as one more time. So we'll look at a pink one here. So this is for the pink area below. What you just solved for there was the green area. Okay, so for the area of the pink section here, I need to have my width here again, much like I did on the first time. The total distance from top to bottom is 7. And so if I take 7 and minus off that x, that's just that bottom chunk, I'm left with just this piece here that I need. So I'm still going to have 7 minus x as kind of the height or length or whatever you want to call it for that part of the pink. And then I need to figure out what this section along the bottom of the pink is, my base. And I know the total distance is 4x from end to end. And this part here is 1 that I don't need. So I'm going to have 4x take off the one that I don't need, and that gives me the length of the base of the rectangle there. And again, going into doing this into expanded form, like they've asked, times it out. So 7 times 4x gets me 28x. 7 times a negative 1 gets me negative 7. Negative x, watch that negative sign, negative x times 4x gets me minus 4x squared, and negative x times 1 gets you a positive x. Simplifying like terms, here I see I've got a negative 4x squared by itself, 28, and x gets me plus 29x, and minus a 7. And that would be the area for the pink shape. So in situations like this, just be really careful that you're actually solving for the piece they want you to, whether it's the whole region or just a shaded region, and look at how the diagram's laid out to find out the pieces that you need, relying also on your prior knowledge for the area of a rectangle being base times width.